Okay, so this is going to be a quick video on how to fill in the pract that we did. So when we were doing our two half cells, the copper and the iron, the electrons came from the copper half cell and the voltmeter pointed over here to was positive. So it was pointing from here to here if you connected it that way. So you should have got an arrow going from the copper to the electrons going from the copper to the iron. Okay, so that means that something in this half cell is losing the electrons, and we know that the metal is losing the electrons. If it's losing the electrons, it's undergoing oxidation, which means that it's the reducing agent. So the copper metal is the reducing agent. And then it's going to be given to one of these things here. And the electrons, if they're given to the 3+, then they will turn that into the 2+. 3+ meaning that it's lost 3 electrons to become 3+. If I give it 1 electron back, then I've only lost 2. So it's given to the Fe3+, which means the Fe3+ has undergone reduction. It's gained electrons. Reduction is the gain. So if it's gained electrons and undergone reduction, then it's the oxidizing agent. Oxidizing agent. Okay, so this is losing, that's gaining, and these are just spectator ions. They're going to be formed more of. All right, so we need to use our page here and copy it across and fill in this. So for the half cells, the anode, so if I drew my whatever's losing, I can do it on either side. I could do it on the left or the right, wherever I want to do it. So this cell is the anode. So remember, oil, anode is the loss, oxidation is the loss, and cat, reduction is the gain. So this is at the anode, that's at the cathode. All right, so I'm just going to make my anode on the left. Name of the electrode, I'm going to make this the anode. What's it made from? So our copper piece of metal is our electrode, so it's made from copper metal. So it's good to put the S in there to show it's solid. The anode is negative for galvanic spontaneous reactions, and the cathode is therefore positive. So that's called the polarity. I really shouldn't write charge. I need to change this and call it polarity. The polarity of each. All right, so we've done the anode, we've done the cathode, and we've done the polarity. So just check that you're doing all of these things for each of this. The direction of the electron flow, so we know that the electrons are coming from this way, and if you plugged this in on the left and that in on the right, then it would have been no, not negative. It would have been, nothing written there, so it would have been positive, meaning the electrons were coming from here to here with your voltmeter. All right, what is the electrode made from? So this one, we had iron, lots of ions in the solution. So ions in the solution, so you've got Fe3+ ions floating around and Fe2+ ions floating around down in here, aqueous. So because we don't have a solid for our electrode, then this dark, and I don't think I mentioned it during the prac, the black kind of electrode is graphite. You might remember graphite is made of carbon. It's made of sheets of carbon, and between those sheets you've got delocalized electrons which can move. So this can conduct electricity. So we just need some sort of solid that the electrons can flow through and be given to the ion here. Ions in solution, so you have copper ions floating around in here in this half cell, and the salt bridge ions in their direction. So the salt bridge is always potassium nitrate. Okay, the salt bridge has to be made of something that is not going to form a precipitate, so potassium or sodium. You could use sodium nitrate. they never form precipitates, and nitrates don't form precipitates. So whatever other ions are in here, you're not going to, because the point of this salt bridge is to balance the negative, to complete the circuit. So to balance the flow of negative charge over to here. So to balance negatives, you have your positive moving into this half cell to balance the negatives, and because you're losing negative over here, your nitrate will come out of this salt bridge and flow into here. Alright, and we had to make sure that was soaked. Alright, so that should be all you'll be doing. Some of the iodine half cell is with graphite as well, and the zinc half cell has a zinc metal. And then otherwise, if you write this around the other way, so if you had your electrons going that way, then that's the anode, that's negative, etc., etc. All right, so fill it all in for the rest of those. Okay, so once we've done that, then we need to do our half equations. So the reaction type, we know that copper was losing the electrons. So copper is losing electrons, undergoing oxidation. And the iron is gaining them. So it was undergoing reduction. So we need an oxidation half equation. Electrons don't have a state, so don't throw aqueous on there. And don't forget the negative, so the two positives, two negatives balance, so there's no charge over here altogether, and there's no charge over there altogether. So just make sure that your charges are correct. And then you've got your ions, aqueous floating around, and they gain one electron, and become Fe2+. So iron that's only lost 2 electrons rather than iron that's lost 3 electrons. So if we add it up, sorry, I've made a bit of a mess in that, haven't I? If we add it up, we've got 3 positives and 1 negative. So they will cancel out so that we've got 2 positives on this side and 2 positives on that side, so it's balanced. Oh, I forgot I was doing the overall. I'll write the overall down here. Alright, so we've got 2 positives is being lost, but only 1 being gained for each of these. So we need to have this reaction happen twice so that we get each of these 2 electrons being taken by something. So then when we put these 2 together, everything on the left will right. So we've got 1 copper plus 2 iron plus 2 electrons forming a copper. Copper iron plus 2 electrons up here, and then 2 lots of iron Fe2+. Alright, I'm not using this sheet for anything else, so I'll tidy it up. So if you want to do your working out on something else, and then do your nice equation in here. I forgot that I was putting overall equation there, so I'm making a bit of a mess. So we've got 1 Cu plus 2 Fe3 plus aqueous, making 1 Cu2 plus 2 Fe2 plus aqueous. Alright, so the electrons coming from here and going to there. 2 electrons come from here and go to 2 different ions, and then you've made extra copper ions, so the solution will get bluer and bluer. And you've made Fe2+ rather than Fe3+. Alright, hopefully that makes sense.